Hello and welcome to this class 9th to 10th bridge course. In this video, we will talk about polynomials. Polynomials, very important topic, lots of concepts there that you must know when you start your 10th standard. Okay, let us start. Let us take this object. This is a square. Let us say the side of the square is 1 unit. What is the area? Area is x square, which is 1 into 1 equals 1. Let us take a bigger square. So the area would be, in this case, x squared, which is 2 into 2, which is 4. So let's take another example, and I will come to the point I'm making. Let us say the side is 3, so that is x squared is 3 into 3, which is 9. So if you take x, this is what we call as a variable, because the value of x keeps changing. Similarly, when we calculate the perimeter of the square, which is 4x, when x is equal to 1, the perimeter is 4. When x is equal to 2, the perimeter is 8. When x is equal to 3, the perimeter is 9. So what that means is the value of x keeps on changing, and that is the reason we call this a variable, whereas the value of 4 does not change. It is the same throughout. It is part of the formula. It will never change. Okay, now that we talked about variables, we know what is a variable. I have written down a few things here. 4x plus x squared, 4x plus x squared plus 2x cubed, 7 plus 4x plus x squared plus 2x cubed. And I also written the number 7. So these are what are called expressions. Expressions. If you take 4x, that is an expression. 4x plus x squared is an expression. The difference is that this expression has what is called one term. This is called a term. This expression has got two terms, first term and second term. Similarly, this has got 3 terms and this has got 4 terms. And what is meant by a term? A term is just a part of an expression which can simply call a variable into a constant. A variable into a constant. If you take 4x, I'm writing 4x here, which is 4 into x. X is called the variable, and 4 is a constant value, but there is a specific term for that. It is called the coefficient. It is called the coefficient of x. So if I take this equation here, if I take this expression here, 4x plus x squared plus 2x cubed, 2 is called the coefficient of x cubed, 4 is called the coefficient of x, and in this case, the coefficient of x squared is 1 because x squared can be written as 1 into x squared. Okay, just to summarize the last 1 minute, we talked about a variable and we talked about term. A term can be loosely called as a constant multiplied by a variable, but the variable, the power of the variable can be anything. It can be x cubed, it can be power 3, it can be power 2, or it can be power 1. And when it is attached to a variable, this constant is called the coefficient. And together, a number of terms is called an expression. Number of terms is called an expression. So all these are expressions. And all these are also called polynomials. These are all expressions. And these are also called polynomials. So the question is, why are they called expressions and why are they called polynomials? In which cases they are expressions, in which cases they are polynomials. Now I want you to understand what is the difference between a polynomial and an expression. So I have taken these two expressions and written it down and compare these two. 7 and 7, 4x, okay, x squared, 2x cubed. The only difference is here we have 4x, here we have 4 root x. But the first one is called as a polynomial expression. The second one is just an expression. It is not a polynomial. Why? Because here we have 4x, here we have 4 into root x. In the case of a polynomial, the power of In the case of a polynomial, the power of the variable x will have to be greater than or equal to 0. In this equation, the power of variable x is 1 by 2. So 1 by 2 is less than 0, so this cannot be a polynomial. For an expression to be a polynomial, the power of x must be greater than or equal to 0. This is something that you have to remember very carefully. Okay, so just to summarize what we learned in the last 30 seconds or so, a polynomial is an expression where the power of the variable x is greater than or equal to 0. It cannot be less than 0. It can also, it cannot be half, 3 by 2. It has to be whole numbers. It has to be whole numbers. In the case of an expression, the power of the variable need not follow this condition. It can be anything. So that is the difference between polynomial and expression. And while we're talking about it, all polynomials are expressions. All polynomials are expressions, whereas all expressions are not necessarily polynomials. Expressions can be other than polynomials. So you just have to keep that in mind. Okay, so now that we talked, we know what is the difference between expression and polynomial. Let us look at all these polynomials. What is the highest power of this polynomial? 3. So this is called a cubic polynomial. This is called a cubic polynomial. In this case, the power is 2. The power of the highest power of the variable is 2. So this is called a quadratic polynomial. Quadratic polynomial. Here, the power of x is 1. So this is called as a linear polynomial. And now, when we come to this number 2 is a constant, right? But it is also a polynomial. So it is called a constant polynomial. And by the way, if you're wondering why I wrote 0 here, 0 is also a polynomial. It is called a zero polynomial. It is called a zero polynomial. Okay, now we have classified the polynomials based upon the highest power. So there is a special name for the highest power of the polynomial. It is called degree. So if you take this polynomial, the degree is 3. The degree is 3 because 3 is the highest power of the variable. Here the degree is 2, here the degree is 1, here the degree is 0. So 2 can be written as 2 into x to the power of 0. X to the power of 0 is 1, so the degree is 0. So in the case of 0, it is a polynomial. It's called a zero polynomial, but it does not have a degree. There is no concept of degree for zero polynomial. There is no concept called degree. Okay, just to summarize the last few seconds, the degree is the highest power of a polynomial. Here it is 3, here it is 2, here it is 1, here it is 0, and zero polynomial does not have a degree. Okay, we will just do a quick example to see the difference between expression and polynomial. So is this an expression? Yes, it is an expression. X squared plus 2 is an expression. Root x plus 4 is also an expression. But is this a polynomial? It is a polynomial, x squared plus 2, because the degree of degree of x is 2 and 2 is greater than 0. In this case, is root x plus 4 a polynomial? It is not a polynomial because root x, the power of x is 1 by 2, and 1 by 2 cannot be, anything in fractions cannot be the degree of a polynomial, so this is not a polynomial. Same case, if you write 1 by x plus 2 plus 4, it is not a polynomial because you have x in the denominator. Both of these are expressions. Both of these are expressions, but they are not polynomials. Okay, now let us look at certain categories of polynomials. When I say categories, let's look at this. This polynomial has 1 term, 2 term, 3 terms. This has 1 term and 2 terms, and this has only 1 term. So it has 3 terms. This is called a trinomial. A polynomial with 3 terms is called a trinomial. A polynomial with two terms is called a binomial, and a polynomial with one term is called a monomial. For example, if you take x, that is also a monomial. If you take 2x, that is also a monomial. If you take 2x plus 2, there are two terms, so it's called a binomial. Okay, so we have classified polynomials into trinomial, binomial, and monomial based on the number of terms, but you should not confuse that with the degree. In this case, the x square, the power is 2, highest power of this polynomial is 2. 2 is a degree. Here, 1 is a degree. Here, 0 is a degree. But based on the number of terms, you call it trinomial, binomial, or monomial. Okay, now we are going to be talking about what is called the value of a polynomial. So these two polynomials, if you take, these two are polynomials, obviously. And polynomials can also be written as P of x or Q of y. I'm sorry, this should be x. And this is a normal way of representing polynomials. I can also write R of t is equal to t squared plus 1. This is a polynomial. It can also be written as R of t or Q of x or P of x. Now, if I take this polynomial P of x is equal to x squared plus 2x plus 1, I substitute the value of x is equal to 4. So it is called P of 4, which is 4 squared plus 2 into 4 plus 1. And this is 16 plus 8, 24 plus 1, 25. 25 is called the value of the polynomial at x is equal to 4. So when you put the value of x is equal to 4 in this polynomial, you get a value, and that is called the value of the polynomial at x is equal to 4. Similarly, you can substitute x is equal to 3, and whatever you get, that will be the value of the polynomial at x is equal to 3. Now, something very important. Okay, now I take this polynomial, and I'm going to substitute x is equal to minus 1. So it will be called P of minus 1, and what is that? Minus 1 square plus 2 into minus 1 plus 1. This is 1, this is minus 2, this is 1, and is equals to 0. So when you substitute a value of x and the value of that polynomial becomes 0, then x is called the 0 of the polynomial. The 0 of the polynomial. In this case, x is equal to minus 1. So minus 1 is called the 0 of the polynomial p of x. 0 of the polynomial p of x. Similarly, whenever you substitute a value for x and the value of the polynomial comes to 0, it is called the value of x is called the 0 of the polynomial. Okay, in the previous example, if you remember, we substituted minus 1 for x and p of x is 0. So minus 1 is a 0 of that polynomial. So let us take another polynomial x squared plus 3x plus 2. If you substitute x is equal to minus 1 or x is equal to minus 2, q of x will be 0. That means this polynomial has two zeros. Let us take this polynomial, x plus 7. If you substitute x is equal to minus 7, then r of x is 0. So in this case, it has only one 0. And here, if you take this polynomial, it will have three zeros. And the number of zeros depends upon the degree. So for the degree 2, you will have two zeros. Degree 1, you will have 1 0. Degree 3, you will have three zeros. So the number of zeros of a polynomial will depend on the degree of the polynomial. Number of zeros is equal to the degree of the polynomial. Again, a 0 of a polynomial is a value where if you substitute that value instead of the variable, the value of that polynomial is 0. Okay, now we come to a very important concept. Let us take this polynomial x squared plus 3x plus 2. I can rewrite this polynomial as x plus 2 into x plus 1. Similarly, x squared plus 2x plus 1, I can rewrite it like this, and same thing here. So what I'm doing is that I'm breaking this polynomial, I'm rewriting it into two factors, a into b, something into something, something into something. So this process is called factorization. Factorization of the polynomial is basically writing it into a number of factors, multiples of factors. So the process of factorization, we won't have enough time to go into how to factorize a polynomial because this is a bridge course. But if you don't know factorization, if you don't understand it, I suggest you go through it and understand it before you move to the 10th standard because it is very important. But just be aware that factorization is the process of rewriting the polynomial or breaking it into factors. Okay, so one more concept before we go to the last step or the last part of this video. Let's take a polynomial x squared plus 3x plus 2. I substitute x is equal to minus 2 and I get the value of 0. So if I substitute x as minus 2 and I get the value of 0, then x plus 2 is a factor of polynomial p of x. If you look at this polynomial here, x plus 2 is a factor. So if I substitute minus 2 and if it's 0, then x plus 2 is a factor. If I substitute minus 1 and if I get the value of 0, then x plus 1 is a factor. So this is called the factor theorem. This is called the factor theorem. And this is an important theorem which you will need to understand before you go to the 10th standard. Okay, so finally in today's topic, we have come to what is called algebraic identities, and I'm pretty sure that you know about this. But let's just go through one or two of those. X plus y is whole square is equal to x squared plus 2xy, so 2xy, x squared plus 2xy plus y square. X minus y the whole square is x square minus 2xy plus y square. Similarly, x square minus y square, x plus a into x plus b, and the same for the cubes. So all these algebraic identities, I'm pretty sure you must have seen before, you must have used before, but you must know all of them very well because you will see a lot of problems in 10th standard which use these algebraic identities, not only in 10th, 11th, 12th, wherever you go, for the rest of your life, wherever you're studying mathematics and science. Okay, there are one or two identities that I've left out. I only written some of the common ones here. But yes, so with this, we will conclude this video. I would like to continue talking and we can talk more about polynomials. But I think what we have seen so far is a good summarization of what you have learned in class 9 as far as polynomials is concerned. I will see you in the next video. Thank you for watching.